Hi everyone, we are graduate students from Indiana University Bloomington, and our project is titled Close to Harvesting and Polluting Emoji to Empower LLM Agents. So my name is Jan, and this work was done in collaboration with my teammates Chan. So in this presentation, we will introduce new security threats targeting emoji to enable LLM systems. We will discuss this novel threat in detail and demonstrate how we verify this in the wild using a threat scanner we developed. So let's consider a scenario where a user wants to make an informed decision, financial decision. So the user might interact with financial agents about investment plan, like in these slides. To handle this request, the agent leverage multiple tools such as financial news API, stock data API, and data analyst. So the decision of which tool to use and in what order depends on the LLM's reasoning capabilities. This sequence, called the control flow of the agents, determines how tasks are executed to fulfill users' request. For example, the LLM might first search for market trends using a financial news API, retrieve data through the store data API, and do some data analysis based on this. The key point here is that the LLM's reasoning entirely drives the control flow. So however, this reliance introduces some security risks. Attackers can exploit LLM decision-making by inserting malicious tools into the workflows. For example, a tool like company to ticker claims to convert company names into the ticker names, matching the input needed for the financial news API. So by tricking the LLM with the misleading descriptions, the malicious tool can collect sensitive information or inject incorrect information into the analysis by injecting into the workflows. So in our projects, we identify 7 attack vectors categorized into semantic hooking and the syntax format hooking. In semantic hooking, attacker trick the LLM's reasoning by posing as tools for external dependencies, error handling, prompt handling, etc. And in syntax format hooking, malicious to exploit workflow requiring specific data formats such as domain-specific inputs or general formats like JSON. So using these methods, attacker can insert their tools into the workflow, enabling 2 key attacks: data harvesting and information polluting. To validate these threats, we designed a threat scanner based on an LLM agents. The scanner takes a target tool's name and descriptions, uses in-context learning to generate malicious tool candidates, and tests them in a simulated control flows. The testing agents evaluate 2 key attack vectors, attacks mentioned before, data harvesting and information polluting. We measure the success rate of the hijacking, harvesting, and the polluting to identify the two vulnerabilities. So in our evaluation, we applied our threat scanner to measure agent development framework, LangChain, and the Llama Index. We tested a total of 73 tools from these 2 platforms. To summarize the results across both platforms, 80% of tools were vulnerable to hijacking, 78% to data harvesting, and 31% to information polluting, which indicates a large portion of tools in the wild are actually vulnerable to our proposed threats. So that's it for our presentation, and please check our report for more details.